Hi everyone, in this video I'm going to walk you through part A and part B of my machine learning assignments. In part A, I used a decision tree classifier to predict COVID-19 mortality based on different symptoms and health conditions. I will explain the code, the visualizations and results, and also how everything we learned in class from data processing to evaluation connects directly to this project. The first thing I did was importing my libraries and load the dataset pandas for reading the CSV, NumPy for numerical operations, Matplotlib, and Seaborn for visualizations. This is exactly what we learned in the early weeks of our course. Once I loaded COVID underscore data.csv, I looked at the first few rows to understand the structure. My dataset includes features like age, gender, vaccination status, fever, cough, diabetes, hypertension, and more. And the target column is mortality. This fits perfectly with our lecture topic about supervised learning, where I have a labeled outcome. Next, pre-processing and cleaning. I had to pre-process the data, in which something we practiced multiple times in labs. My dataset had two categorical columns: gender, vaccination underscore status. Decision tree needs a numerical input, so I used one hot encoding with pd dot get underscore dummies. This convert each category into binary columns like gender underscore male, gender underscore female, vaccination underscore status underscore full vaccinated, vaccination underscore status underscore unvaccinated, etc. This steps connects directly to the course learning outcomes about data cleaning, features encoding, and preparing data for ML models. After that, I separated the dataset into X and Y. This is something we practiced in our classification labs. Then train test split to evaluate the model fairly. I learned to split data using train test split. And I used test underscore size equals to 0.30. This ensures 70% of the data is used for training and 30% for testing. This reflects the lesson on avoiding overfitting and testing my model on data it hasn't seen before. Next, train decision tree. For the model itself, I used decision tree classifier max depth 5. I learned in class that decision trees are intuitive. They can handle both numerical and categorical variables. They split data based on conditions. Max underscore depth prevents overfitting. The model is trained with feed, and predictions are made with dot predict. These relatives are directly to our lectures on classification algorithms, decision tree theory, entropy, information gain, and splitting criteria. Next, after that, I measured the model's performance using accuracy score, classification report, confusion metrics. These metrics were taught in class as part of model evaluation. Accuracy, I printed the accuracy to see how well the model predict mortality. Next, confusion metrics. I created a heat map to visualize true positives, true negatives, false positive, false negatives. This connects to our lab, where we interpreted confusion metrics for medical datasets. Next, features are importance. This visualization shows which features contributed most to predictions. I learned in lectures, and features importance helps interpreted decision trees, and explaining why a model marks certain decisions. In my result, clinical features like age, fever, vaccination status, and certain comorbidities are ranked higher, which makes sense medically. Next, tree visualization. Here I use load underscore tree model field equals true. This allows us to see the actual logic of the tree, which features it splits on at what threshold, and the predicted outcome at each leaf. This directly relates to the course topics on model inter interpretability, where decisions trees are one of the most interpretable ML models. It helps explaining why the model made each prediction, which is very important in healthcare application. Next, part B, pandas data cleaning and analysis. I started by importing pandas and matplotlib, which we used throughout the courses for data manipulation and visualizations. I use df equals to pd.read underscore csv as n2.csv, the CSV file. This follows the course module on data ingestion, where we learned how to load CSV files into a data frame and inspect the first few rows. I displayed the shape and head, so I understand the structure and confirm that the dataset loaded correctly. This is the same workflow we practiced in the labs: load, check, clean, analyze, and visualizations. Next, data cleaning, like deleting a model from column. I use df.drop bracket columns equals model in place true. From lectures, we learned that datasets often contain irrelevant features. Since model wasn't needed for our analysis, I removed it. This prevents unnecessary clutter and follows the course outcome about pre-processing and features section. And then cleaning cost, removing cost permanently. The cost column contains symbol like third bracket and dollar sign. Using uh, df cost I removed all unwanted characters. This comes directly from our lab exercise on string manipulation, regex cleaning, and handling messy data. Next, converting cost into integer. I use df cost equals df cost dot as type int. This step is important because numerical analysis requires numeric types. In lecture, we learned that data types matter for calculations like mean, histogram, and grouping. Doing this conversion ensures consistency and avoids silent errors later. Next, average of cost. This connects to our topic on descriptive statics, mean, median, mode, which helps us summarize datasets quickly. And next, average cost per continent. I use df group by continent, third bracket cost dot mean. This demonstrates group by operations, which were a major part of our lab. Grouping allows us to find insights inside categories like the typical cost for each continent. Next, mean of numerical columns grouped by continent. Uh, this part ties into our visualizations lectures where we discussed how visualize summaries reveal patterns more clearly than raw numbers. Bar charts are ideal for comparing groups side by side. Next, count occurrence for each continent. I use value underscore counts, unique and n- unique histogram with 500 bins. Sorry, histogram with 50 bins. This helps reveal how often each continent appears, how cost values are distributed, whether the data is skewed. This aligns with course learning outcomes on exploratory data analysis, which helps us understand data before building models. Next, handling missing value. I use df dot isna bracket dot sum. Lectures emphasized that missing data can break models, so identifying and addressing NS is essential, and replacing missing data type with the triple X. I use df third bracket type equals df type fill NA xxx. This is a data imputation technique. We learned multiple strategies: dropping, filling with mean, median, or using placeholders, where I used xxx because type is a categorical feature and using a placeholder avoids destroying the meaning of actual categories. Then dropping rows with any missing values. I use df underscore dropped equals df dot drop na. This gives us a fully clean dataset. Then I use df underscore dropped dot describe and even fetch a specific element. I use disk dot ilog 0 comma 2. This shows how we can programmatically access summary statistics, something we practiced in lab. Then sorting and saving. I sorted by frequency alphabetically. This shows different ways to ordering categorical data, which we used in multiple exercises during the course. And saving, I use df.to underscore csv assigned to underscore data underscore client dot csv index equals false. This follows the workflow of exporting client data, allowing us to use it for future task modeling or sharing. Next, reasoning behind my choice. I removed the model column because it didn't support any of the analysis goals. I cleaned cost because symbols are preventing numerical operations. I converted types early to avoid bugs later. I used a group by and descriptive stats to extract meaningful patterns. I added histogram and bar charts because visual insights helps communicate results better. I replaced missing values through thoughtfully. Categorical data requires a placeholder and doesn't distracted categories. So all of these decisions align directly with the course models on data cleaning, data transformation, exploratory analysis, and preparing data sets for real world tasks. So that's all was for assignment 2. Thank you for watching the video.